Today in MT5506L practical based on mathematical programming, we are reached to the practical number 10 problem based on BGAM and two-phase method. We are starting the third problem in this practical. Today we are discussing about the problem based on two-phase method. So here is the problem. Maximize z is equals to 5x1 plus 8x2 subject to constraints 3x1 plus 2x2 greater than or equals to 3, x1 plus 4x2 greater than or equals to 4, x1 plus x2 less than or equals to 5. So the first of all, x1 and x2 are greater than or equals to 0. So the standard form of given LPP is maximize z is equals to 5x1 plus 8x2 subject to constraints 3x1 plus 2x2 minus s1 is equals to 3, x1 plus 4x2 minus s2 is equals to 4, x1 plus x2 plus s3 is equals to 5, x1, x2, s1, s2, s3 all are greater than or equals to 0. Here 0 s1 plus 0 s2 plus 0 s3. Okay. So this is the standard form. But if from this we start with as an initial basic possible solution, then for initial solution, let x1, x2 be 0. Then s1 is equals to minus 3, s2 is equals to minus 4, and s3 is equals to 5. So it is not a feasible because this is less than or equals to 0. So it is not a feasible. So we have to introduce the artificial variable. So in first and second constraint we will introduce the artificial variable. So now our problem, the constraints I am writing only. So the constraints are 3x1 plus 2x2 minus s1 plus a1 is equals to 3, x1 plus 4x2 minus s2 plus a2 is equals to 4, x1 plus x2 plus s3 is equals to 5, which of course as previous x1, x2, s1, s2, s3, a1, a2 all are greater than or equal to 0. Now we are going to use the two-phase method. So the phase 1 has the objective function as maximize z is equal to 0 x1 plus 0 x2 plus 0 s1 plus 0 s2 plus 0 s3 plus minus a1 minus a2. Since our problem is maximizing, our coefficients of a1 and a2 are negative. So minus a1 and minus a2. So we are starting from this. So we have to write down the phase 1 simplex table. So for the simplex table again we have to write CB, B, XB, X1, X2, S1, S2, S3, A1 and A2. Their coefficients. So here it is all 0 except this minus 1. In constraints, in basis we are having right now A1 is 3, A2 is 4 and S3 is 5. So in basis we are having A1, A2 and S3. So their values are 3, 4, 5. We have to write that before this. So that is 0, -1 and -1. Let x1, x2, s1, s2 0, then the initial solution is a1 is equals to 3, a2 is equals to 4 and s3 is equals to 5. So those are in basis. Okay? So a1 is equals to 3, s3, a2 is equals to 4 and s3 is equals to 5. Here also we have to make this a1 a2. 3, 4, 5. Their coefficients are -1, -1 and 0. And in table write down the constraints coefficients. So that are 3, 2, -1, 0, 0, 1, 0. Here it will be 1, 4, 0, -1, 0, 0, 1. And lastly here it is 1, 1, 0, 0, 1, 0, 0. Now evaluate ZJ. So it is -1 times 3, so -3, -1 times 1, so -4, -1 times 2 and -1 times 4, so it is -6, -1 times 1, and here it is so 1, and here it is again 1, here it is 0, here it is -1 and -1. Cj minus Zj is 4, 6, -1, -1, 0, 0, 0. So the positive quantity is for these two and larger value is for 6. So corresponding variable x2 will enter a basis. Now we have to identify which variable will leave a basis, that is by replacement ratio. So 3 by 2, 4 by 4, so that is 1, and 5 by 1, so it's 5. So minimum value is 1. So corresponding variable a2 will leave a basis. So we have to make this entry 1. This entry 0 and this entry 0 by array process. So again we have to write down the simplex table. So CB, B, XB, X1, X2, S1, S2, S3 and A1. Now we will not calculate table for A2 because A2 has already left the basis. So in basis round we are having A1, X2 and S3. Their coefficients are -1, 0 and 0. And now to make this entry 1, we have to divide everything by 4. So we are having 1, 1 by 4, 1, 0, -1 by 4, 0 and 0. Now to make this entry 0, we have to subtract from this row. So 5 minus 1, that is 4, 1 minus 1 by 4, that is 3 by 4, 1 minus 1 is 0, 0 minus 0 is 0, 0 minus -1 by 4, so 1 by 4. Here 1 minus 0 is 1 and 0 minus 0 is 0. Now to make this entry 0, we have to subtract from, multiply this row by 2 and subtract from here. So it is 3 minus 2, so it is 1. Here it will be 3 minus 1 by 2, so it is 5 by 2. Here it is 0, here it is -1, here it will be 1 by 2, here it is 0, and here it is 1. So now again we have to evaluate Zj's and Cj minus Zj. So for that Zj is -1 times 5 by 2, so -5 by 2, 0, 1, -1 by 2, 0 and -1. Here coefficients are 0, 0, 0, 0, 0 and -1. So Cj minus Zj is 5 by 2, 0, -1, 1 by 2, 0 and 0. So positive quantity is for this and larger value here, so x1 will enter a basis. So find out which variable will leave a basis by replacement ratio. So here it is 1 by 5 by 2, so it is 2 by 5. Here it is 1 by 4, it is 4, and here it is 4 by 3 by 4, so it is 16 by 3. So minimum value is 2 by 5, so that is corresponding variable will leave a basis. So we have to make this entry 1 and this entry 0 by array process. So again make a table, that is CB, B, XB, X1, X2, S1, S2, S3. Since A1 is leaving a basis, so we will not calculate for A1. So in basis right now we are having X1, X2 and S3. Their coefficients are 0, 0, 0. Now to make this entry 1, we have to divide everything by 5 by 2. So here values are 2 by 5. Here it is 1, here it is 0, here it is minus 2 by 5. Here it is 1 by 5, and here it is 0. Now to make this entry 0, we have to multiply this row by 1 by 4 and subtract this row. So we are having 9 by 10. Here it is 0, here it will be 1, here it will be 1 by 10, here it will be minus 3 by 10, and here it is 0. Now to make this entry 0, we have to multiply this by 3 by 4 and subtract from here. So it is 37 by 10, here it will be 0, here it will be 0, here it is 3 by 10, here it is 1 by 10, and here it is 1. Now if you will evaluate ZJ, everything is 0, and of course his coefficients are also 0, so Cj minus Zj is also 0. So we have reached to the final situation. All variables have left, all artificial variables have left the basis, so we are at the end of phase 1. Now we will move towards the phase 2. So in phase 2, first of all we have to make is copy the whole table except the coefficients. So we will copy that. So this is our table. Just we have to do is to change the coefficients. Okay. So coefficients are now, these are not there. Values are from original objective function. That is original objective function is having coefficients minus 5 and 8. Okay, so we will make to copy that is 5 and 8. So coefficients now here are 5 and 8 for x1 and x2. Here s1, s2, s3's coefficients are 0, so 5 and 8. Now we have to evaluate again zj and cj. Okay, so we will do that. So zj are 5 times 1, that is 5, 8 times 1, that is 8. Now here it is 5 times minus 2 by 5, so it is minus 2. 8 times 1 by 10, so it is 4 by 5. Here it is 5 times 1 by 5, so 1. 8 by 3 by 10, so minus 12 by 5. Here it is 0. Okay. So now Cj minus Zj is 5 minus 5 is 0, 8 minus 8 is 0. 0 minus this, so it is 2 minus 4 by 5, and here it is 12 by 5 minus 1, and here it is 0. So this is 10 minus 4, that is 8 by 5, and this is 5, so 7 by 5. Okay, so which variable will enter a basis, that can be identified from this. So sorry, here it is 5 times 2, it is 10 minus 4, so 6 by 5. Okay, so 7 by 5 is larger, so corresponding variable S2 will enter a basis. Now identify which variable will leave a basis by replacement ratio. So that is 2 by 5 by 1 by 5, it is 2. 9 by negative, so it is infinite. 37 by 10 by 1 by 10, so it is 37. So minimum value is 2. So corresponding variable will enter a basis. So we have to make this entry 1 and this entry and this entry be 0. So for doing that, we will again apply the RRE process, that is CB, B, XB, X1, X2, S1, S2 and S3 in basis 1. Now we are having X1 is replaced by S2, so it is S2, X2 and S3. So here coefficients are 5, 8, 0, 0, 0, so here it is 8, 0, 0. Now to make this entry 1, we have to divide by everything by 1 by 5, so means multiply by everything with 5, so 2, 5, 0, minus 2, 1 and 0. Now to make this 3 by 10 0, we have to multiply this by 3 by 10 and add here. So we are having here 3 by 2, 3 by 2, 1, minus 1 by 2, 0 and 0. To make this entry 0, we have to multiply this row by 1 by 10 and subtract from here. So here we are having 7 by 2 minus 1 by 2, 0, 1 by 2, 0 and 1. Now again evaluate ZJs. So we are having 8 times 3 by 2, so 12, here it is 8, it is minus 4, 0 and 0. So CJ minus ZJ is 5 minus 12, so minus 7, 8 minus 8, 0, it is 4, 0 and 0. So here it is a positive quantity, so we have to enter this variable in a basis. Now identify the replacement ratio to which variable will leave a basis. So here these two quantities are negative, so here it is infinite, so 7 by 2 by 1 by 2, it is 7, so here this variable will leave a basis. So S3 will leave a basis, S1 will enter a basis. So again apply the RRE process, make a table CB, B, XB, X1, X2, S1, S2 and S3. So 5, 8, 0, 0, 0 in basis. Now we are having S2, X2 and S1. Coefficients are 8, 0, 0. Now apply the RRE process. So first of all, we have to make this entry 1 and then apply process to get this entry 0. So to make this entry 1, we have to multiply everything by 2. So here we are having 7 minus 1, 0, 1, 0 and 2. Now to make this entry 0, we have to multiply this row by 2 and add up here. So 14 plus 2, so it is 16 Here it is minus 1 times 2, so here it will be 3, here it will be 0, 0, 1 and 4. Now this to make this entry 0, we have to multiply this, directly add this row to here, so we will get that. So 3 by 2 plus 7 by 2, it is 10 by 2 plus, so it is 5, answer is 5. Now here it will be similarly 1, here it is 1, here it is 0, 0 and 1. Now apply similarly that ZJ, here it is S1. So ZJ is 8, here it is again 8, here it is 0, 0 and 8. So Cj minus Zj is 5 minus 8 is minus 3, 8 minus 8 is 0, 0, 0 minus 8. So all Cj minus Zj's are less than or equal to 0. So this is an optimal solution. So the optimal solution is reached. So maximum value of Z is reached at x1 is equal to 0, x2 is equal to 5 and the corresponding value of Z is equal to 5x1 plus 8x2, that is 5 times 0 plus 8 times 5, it is 40. So this is how we can reach to the optimal solution by two-phase method. As we have seen in theory, you have to write down this as in a practical book. Again, I am saying that in a practical you have to write everything in a A4 size paper. So we will do the another problem tomorrow. So till that, stay at home and stay safe. Thank you.